It's math time with Hines. It's math time with Hines. Math time.
Hi everybody, on today's show we discuss an alternative way to write inequalities. So instead of writing them as x is greater than 2, we're going to come up with a different way to write inequalities. So graph the solution set to both of these inequalities on the set of axes below. So I have x is less than or equal to 7. 7 gets a closed circle, and I'm less than it, so I'm shading to the left. And then I also have x is greater than negative 3. So here's negative 3, open circle because it's not included, and I'm greater than it, so I'm shading that way to the right. What values make both of them true? Well, that's going to be the overlap. What values make both of them true? So how low can I go? Well, negative 3, but it's not included. All the way up until 7, which is included. So the way that we're going to write this is we're going to say x is trapped between negative 3 and 7. I can't be negative 3. X is bigger than negative 3. Read that way. Negative 3 is smaller than x, which is less than or equal to 7. So it's always less than signs that you use here. X is bigger than negative 3, while x is less than or equal to 7. So it's from negative 3 all the way until 7. It's that purple overlap region there. Negative 3 is not included, but 7 is. So we can use interval notation to represent the solution sets to inequalities. Graph each of these here. So, how low can I go? Negative 3 all the way until 5. This is saying x, lowest it goes is negative 3, the highest it goes is 5. And I touch every single number in between there. Every decimal and every integer and every irrational, every real number between negative 3 and 5. Negative 3 gets a closed circle, it's included. 5 gets a closed circle, it's included. And I'm shading in between because x is trapped between those two. So using interval notation is we kind of simplify it. We go from negative 3 to 5. We're going to use a comma. And then we're going to use square brackets because it's included. We're going to use square brackets because I have that equal to, I have a closed circle. So if I have a less than or equal to, a greater than or equal to, a closed circle, it gets a bracket, a square bracket. All of these go together here. Square brackets go with closed circles and equal tos. This next one says x is between negative 6 and 4. So x goes between negative 6 and 4. But notice, can I touch negative 6? No. Can I touch 4? No. But I want to be between them. I can't touch them, but I can be any number in between them. So again, it's going to be negative 6. It's always low to high, but I can't touch them, so I'm going to use a set of parentheses. Interval notation, you're either using a bracket or a parenthesis. So the parenthesis goes with less than or greater than signs, an open circle, and you get parentheses. All of these go together. And finally, you can mix and match. If I'm going from negative 4 to 8, so here's negative 4 and here's 8. Can I be negative 4? No. But can I be 8? You bet. I've got an equal to. And I'm going to be in between them. It says x is trapped between them. Using interval notation, I'm going from negative 4 to 8, low to high. I can touch 8, so it gets the bracket. Negative 4 gets a parenthesis. So notice how interval notation can look a little wonky. Don't touch negative 4, but go all the way up to 8 and include it. Graph each inequality as a ray and write the inequality using interval notation. So I have x is bigger than 4. Here's 4, 5, 6, 3, 2. Of course, all those are equally spaced out there. You just aren't seeing them right. Let me fix that. So negative 4. Negative 4 gets a closed circle, and I want to be bigger than it, so I'm shading to the right. Notice this one never ends. So how low do I go? 4. How high do I go? Well, it goes on forever, so we're going to put an infinity there. 4 is included. 4 gets a bracket because I have a closed circle there. Infinity is not really a number. You can never touch infinity, so we're going to put a parenthesis around that. Infinity always gets a parenthesis. Always, always, always. Let's graph the next one. X is less than 5. So here's 5, 6, 7, 4, 3. 5 is not a solution, so it gets an open circle. And I'm less than it, so I'm going to shade to the left. So how low, remember, interval notation goes low to high. How low can I go here? Well, it goes on forever to negative infinity. How high do I go? 5. 5 gets a parenthesis because it's open. Infinities always get parentheses because they're not really numbers. It's an idea that I can get really, really, really negative, or I can get really, really, really positive. One more. Negative 4 is less than x. I hate the way that looks. X is bigger than negative 4. If I graph that, here's negative 4, negative 3, negative 2, negative 5, negative 6. Okay. And I want to be bigger than that. So negative 4, not included. And I want to be bigger than it. So to the right. How low can I go? Well, basically negative 4, but I can't touch it, so it gets a parenthesis. How high can I go? On forever, so that's infinity. So interval notation, it's always lowest to highest, and then you have to decide, do I want a bracket or a parenthesis? State 3 numbers in this interval, 0 to 3. Notice, sorry, that is not 0, that is number 1. 1 to 3. So 1, not included. I have a parenthesis, so that gets an open circle. I can't touch 1. But I can touch 3, so that gets a closed circle. What numbers are in this interval? Remember, this is every number from 1 to 3. Well, 2 is. 3 is included. 2.5, 2.75, 1.01. This is a little bigger than 1's included. 1.9. There's lots of numbers in this interval that are both integers, rational, and irrational. There's lots of numbers you can put in here. I can't touch 1, but I can go all the way up until 3. Write an inequality for each of the solution sets shown below. So here I'm going from negative 5 up until 3. So my x is trapped between negative 5 and 3. X is bigger than negative 5 and bigger than or equal to 3. Always use less thans when you write like this. And notice this is a closed circle, so it got the equal to. That's not included. It didn't get the equal to. Write it in interval notation. So this is negative 5 comma 3, bracket for the 3, parenthesis for the negative 5. I don't want to touch the negative 5. Let's look at the next one. 5, 6, 7. Negative 8 to 2. X is trapped between negative 8 and 2. Can I touch negative 8? No. Can I touch 2? No. X is bigger than negative 8. X is less than 2. I have to be both of those. I'm trapped between there. So using interval notation, low to high, not included, not included. And the next one, I've got negative 1. Do I ever stop? No, it goes on forever. So my x's are bigger than or equal to negative 1. Notice I have the equal to because I have a closed circle. So interval notation, how low do I go? How far left can I go? Negative 1. Do I ever stop? No, it goes on forever, infinity. Bracket for the negative 1, parenthesis for the infinity. Closed circle equal to bracket. Closed equal bracket. One more. 0, 1, 2, negative 3. How low do I go? Well, I go on forever. So my x's are less than negative 3. Here's negative 3. I want to be less than them. So using interval notation, how low do I go? Negative infinity. That's how low. It goes on forever. How high does it go? Negative 3, but don't touch it, and you can't touch infinities. Consider the interval 5 to 9. State all the integers in this interval. So 5 to 9. 5, 6, 7. Remember, the integers are these nice numbers here that I'm writing down. 5 gets a closed circle. 9 is not included. This is an open circle there, and I'm in between there. So what are all the integers? 5 is an integer. 6, 7, 8. Do not write 9. 9 is not included. Explain how you arrived at your answer. I drew a picture. I drew a graph and wrote all the integers down. Integers in the solution set. Number 6, solve both of the following inequalities and graph their solution sets on the same number line. State in interval notation the values that make both of them true. So let's take a second and solve both of these. Pause the video and see if you can practice solving both of these inequalities here. So I need to distribute negative 5x minus 30. I'm going to add 8x. Negative 21 is less than or equal to 3x minus 30. Add 30. 9 is less than or equal to 3x. 3 is less than or equal to x. So x is bigger than or equal to 3. Then the second one here, which I'll do in green, you need to distribute. And distribute again. Okay. Combining like terms, negative 24 and negative 12 makes negative 36. If I add that 8 over, maybe wasn't the first move you made, and I actually regret making that move, but that's okay. That's okay. We can keep going on. Negative 28. You probably did this a different way, but we're going to end up with the same answer, which is great. I now have to divide by negative 4. Warning, warning, warning. Whenever you divide by a negative, flip that sign. X is less than 7. So it says graph both of the solutions. So I've got 3 to 7. Bigger than 3, while being 7, don't touch it, smaller than it. So what makes both of them true? That's the overlap from 3 to 7. So this is 3 bracket to 7 parenthesis. That's my answer. Any number in there makes both of them true. If I plugged in 4, they're both true. Because look, it's in the overlap of their solution sets. What we're graphing here is the numbers that make them true. State the integer values. Well, what are the integers? Well, does 3 work? Yep. Does 4? Yep. 5, 6. Does 7? No, 7 doesn't work because it's got that open circle for this one. It works for the blue, doesn't work for this one. So 3, 4, 5, and 6 are the integers that work for both. I'll see you in the next lesson, which will actually be in the next unit. So that was Unit 1. That was our equations and inequalities unit. Hopefully this was a good review / learn some new things just to get us set up for the rest of the year. See you in Unit 2.